Good evening, everyone, all the participants. I hope you are doing well and you are enjoying the videos as well as also you are going for the assignments, whatever has been submitted to you. Uh, Now, before starting, let me tell you one thing. I think it is better before answering the questions. Uh, Let me just tell you one thing, that is, whenever you are solving the problems of Fourier transform, in the lectures, we have used the kernel as e power I alpha x. Please note that. We have used the kernel as e power I alpha x whenever you are finding the Fourier transform. Various books has used some other type of transforms also. And similarly, so this kernel we have used for Fourier transform, and for inverse Fourier transform, we have used e power minus I alpha x. So please note this thing, that whenever we have solved problems on Fourier transform, we have used the kernel as e power I alpha x, whereas for inverse Fourier transform, e power minus I alpha x. Although one can use some other kernel also, the opposite one also, in various books you will find various other type of kernels. Since we have used this normal notation throughout the lectures on Fourier transform, so I will request all of you, whenever you are submitting the assignments, you are doing the assignments, use the same kernel e power I alpha x to find the Fourier transform, whereas e power minus I alpha x for finding the inverse Fourier transform. And please follow the same thing in the examination question paper also. Although we have not written, but I am just saying, we will write it in forum also, this part, that in exam paper also, wherever you are solving problems on Fourier transform, please use the kernel as e power I alpha x, and for inverse Fourier transform, use the kernel as e power minus I alpha x. Now I think, let me come to the question. uh, Subham Roy has asked a question. Any engineering mathematics book to tricky and quickly solve problems? Basically, you want the name of some books. So you may use these two books. Quickly you cannot solve, obviously, because these problems will take some time, but you will get enough insight if you go through these two books. One is Integral Transforms and Their Applications by B. Daries, Daries. Other book you can use The Use of Integral Transforms by Ian Snedden. Okay, so you may use any one of these two books, book by B. Daries or by Ian Snedden. If you wish, you will get more insight, which we could not cover due to time constraint and other things. So this was the question of, I think, Subham Rai. So Subham, if you have any other query, just post it in the YouTube if you have anything else. Next one is, who has written it? Hmm? Alum or what is alum? Alum and Kanchunde or what?
Alum has asked for Abel's integral equation. Kanchunde has asked for Bessel function.
Okay, Kanchunde I will come later. Now, Alam has asked for, please discuss Abel's integral equation. Although these are lengthy, I will try to do it quickly as far as possible. The Abel's, if you see, integral equation is phi t equals 0 to t fu by t minus u to the power alpha into du, where alpha belongs to 0, 1. So phi t is 0 to t fu t minus u to the fu divided by t minus u to the power alpha du. Alpha belongs to 0, 1. Please note that your function phi t is unknown. Phi t is unknown function, whereas, phi t is, phi t is known function and your ft is unknown function. Okay. So effectively your basic aim is to find out the unknown function over here. So this integral equation is there where phi t function is known and ft is unknown. We want to find out, we want to solve this integral equation using Laplace transform. So your phi t is given as 0 to t fu into divided by t minus u to the power alpha du, which the same thing you can write down phi t equals, using convolution, you can write it as ft into gt, right? Using convolution property, you can write down phi t equals ft star gt, and where gt is nothing but t to the power minus alpha. So now you take, once you are writing phi t as ft star gt, you take Laplace transform on both sides of the above equation so that you will get Laplace transform of phi t. This is equals Laplace transform of ft convolution gt, and again using the property, I am not going in details. This you can write down Laplace transform of ft into Laplace transform of gt. So ft is unknown to us, whereas gt is known to us. Gt is t power minus alpha. So this equals, you can write down Laplace transform of ft into Laplace transform of t power minus alpha is gamma 1 minus alpha s to the power 1 minus alpha. Please note here that alpha belongs to 0, 1, which implies minus alpha is greater than minus 1. And from there, we have written Laplace transform of t to the power minus alpha is gamma 1 minus alpha divided by s to the power 1 minus alpha. So that from here, you can write down your Laplace transform of ft is equals to s to the power 1 minus alpha by gamma 1 minus alpha into Laplace transform of phi t. This you can write down. Now, Laplace transform of phi dash t, from property you can write down Laplace transform of phi dash t this equals s into Laplace transform of phi t minus phi 0. And this value, phi 0, if you use, phi 0 is nothing but will be 0 because phi 0 is equals to 0 to 0, 0 to t was there. So if you by t minus u to the power alpha into du, so that this is 0. So your phi 0 is 0. So that you can write down Laplace transform of phi dash t. This is equals to s into Laplace transform of phi t. And from here, you can write down Laplace transform of phi t. This is equals 1 by s Laplace transform of phi dash t. So if you put this value of Laplace transform of other equation, that is earlier equation where we have written Laplace transform of ft equals s to the power 1 minus alpha by gamma 1 minus alpha into Laplace transform of ft, phi t. There if you put it, you will obtain Laplace transform of ft equals s to the power 1 minus alpha by gamma 1 minus alpha into 1 by s Laplace transform of phi dash t. So that this equals, you can write down just by making 1 by gamma of 1 by 1 minus alpha Laplace transform of phi dash t into this s, if you bring it down 1 by s. This again you can write down as just after simple calculations, gamma 1 minus alpha gamma alpha into Laplace transform of phi dash t into Laplace transform of t to the power alpha minus 1. Because I have added here gamma alpha, so that this term effectively will become gamma alpha by s to the power alpha, which is nothing but the Laplace transform of this. Because, and also we know that gamma alpha into gamma 1 minus alpha is equals to pi by sine pi alpha. So that this equals, you can write down pi by, sorry, opposite one will come, means it will be sine pi alpha by pi into Laplace transform of, again using the properties of convolution, you can write down Laplace transform of phi dash t into t to the power alpha minus 1. So please note that Laplace transform of ft is equals to sine pi alpha by pi into Laplace transform of phi dash t convolution t to the power alpha minus 1. So from here, we can write down Laplace transform of ft. This is equals to sine pi alpha by pi into Laplace transform of phi dash t star. The last one was same thing I am writing here, star t to the power alpha minus 1. So now on this, if you take the inverse Laplace transform on both sides, then you will obtain ft equals sine pi alpha by pi into phi dash t convolution t to the power alpha minus 1, just taking the inverse Laplace transform. And this equals, you can write down sine pi alpha by pi 0 to t, just using the definition of convolution, phi dash x into t minus x whole to the power alpha minus 1 into dx. So basically, this is the solution for the Abel's integral equation. Please note that originally, if you see, originally your problem was this thing, phi t equals 0 to t fu by t minus u all to the power alpha du, where phi t is known and ft is unknown. We have to find out the value of ft from this integral equation. So using Laplace transform, we are solving this, and ultimately ft you are getting sine pi alpha by pi 0 to t phi dash x into t minus x whole to the power alpha minus 1 into dx. So that if I know phi x, I can find out phi dash x, and if I evaluate the integral, then I will obtain the solution of this function ft. Anything else is there? Any other question? Okay. So I think Alam, you got what is integral equation and how to find out the value of the unknown function from integral equation using Laplace transform. If there is any further query, please post it. Let me go to the next one, that is by Jayanto Roy. Please discuss assignment 6, question number 2 and question number 5. Uh, question 2. Question 2 is fx equals delta x minus 1 minus x into delta x plus 1. And you have to find out Fourier transform of fx. So Fourier transform of fx from the definition 1 by root 2 pi into minus infinity to infinity fx into e power I alpha x dx. Now your fx is this one. So delta x minus 1 minus x into delta x plus 1 into e power I alpha x dx. So that if you break it into two integrals, you will obtain 1 by root 2 pi minus infinity to infinity delta x minus 1 into e power I alpha x dx minus infinity to infinity x into delta x plus 1 e power I alpha x into dx. Actually, I think you have missed one thing. One thing is there, you can directly evaluate these two integrals. And that becomes really cumbersome, very difficult also to evaluate the integrals, this one. But if you use a trick, here the trick is simply use a property of Dirac delta function. Do you remember the property of Dirac delta function, that is minus infinity to infinity delta t minus a into ft dt. This is equals how much? Delta minus infinity to infinity, sorry, this will not be there. This is the property that minus infinity to infinity delta t minus a ft dt, this is equals fa. If you remember this particular property of Dirac delta function, then very easily you can evaluate the integral. Effectively, first, for the first integral, you are doing nothing. In place of in ft, you are putting t equals a whenever it is delta t minus a. So that for the first integral, simply it will be the value of e power I alpha x at x equals 1, whereas for the second case, it will be the value of e to the power I alpha x when x is minus 1. Because here, for the first integral, your a is 1. For the second integral, your a is minus 1. So please note this property. If I remember this property very easily, I can evaluate it. Otherwise, it will take a long time for us to evaluate the integral. Just 1 minute. Hello. একটা ইয়ের ক্লাস নিচ্ছি এখন একটু এনপিটিএল এর একটা অনলাইন ইউটিউবে চলছে আমি পরে ফোন করে দেবো 7:30। So once I evaluate this one, this will be equals to 1 by root 2 pi e power I alpha. Sorry, let me write down the step, one step more, so that it is e power I alpha x. I have to evaluate it at x equals 1 minus, this is e power x, e power I alpha x, and the value of x here, it will be minus 1. So if you put it, this will become 1 by root 2 pi e power I alpha minus 1 into e power minus I alpha. So that it is becoming effectively your e power I alpha and 1 by root 2 pi. So I can write down this is as 2 by root over 2 pi e to the power I alpha plus e to the power minus I alpha divided by 2. So that it is nothing but cos alpha. So the value becomes root over 2 by pi into cos of alpha. So the answer is Fourier transform of the function fx, where fx is Dirac delta x minus 1 minus x into Dirac delta x plus 1 is this one, root over 2 by pi cos alpha. I hope, Jayanto, you have understood this one. Let me go through your second problem, that is question number 5. Here also, what was the problem? For question 5, assignment 6, I have to find out the Fourier transform of fx, where fx is cos x, mod x less than equals pi by 2 and 0 otherwise. And we have to find out the Fourier transform. So Fourier transform of fx, this is equals 1 by root 2 pi minus infinity to infinity fx e power I alpha x dx. If you substitute the value of this, then the range will be minus pi by 2 to pi by 2, because mod x is less than equals pi by 2. So in all other range, fx is 0. So it will be, your fx is cos x into e power I alpha x dx. So I have to just evaluate the integral. Was there any problem in the evaluation of the integral? Because e power I alpha, I think we can substitute in terms of cos and sine. So 1 by root 2 pi minus pi by 2 to pi by 2 cos x into cos of alpha x plus I sine of alpha x dx. Now break it into two parts. That is, one integral will be minus pi by 2 cos x cos alpha x dx. So that is an even function. The first one is even function. The other one, cos x sin alpha x, that is an odd function. So therefore, the second one will vanish, and you will have, you can write down 2 by root over 2 by pi minus pi by 2 to pi by 2. You can write down 0 to pi by 2, 2 into 0 to pi by 2, cos x into cos of alpha x dx. Please note that The other value is, since it first part was even, so 2 into 0 to pi by 2 you have made. The other value, since it is odd, that is minus pi by 2 to pi by 2 cos x sin alpha x dx. This is odd function, so that the value becomes 0. So now I have to only evaluate this cos alpha, cos x into, sorry, this is not alpha. This is cos x into cos of alpha x dx. So it is again cos A cos B form, and since it is in the cos A cos B form, therefore you can write down this equals 1 by root 2 pi 0 to pi by 2 cos of 1 plus alpha into x plus cos of alpha minus 1 into x dx. So now I think you can evaluate it, because in terms of cos you will get in terms of sine, and ultimately you will put the values over here. But I think the result will come something like this. This will be 1 by root 2 pi. I'm just jumping the step. Pi by 2 plus alpha pi by 2 divided by alpha plus 1 plus minus sine of pi by 2 minus alpha pi by 2 divided by alpha minus 1. And this we can write down 1 by root 2 pi cos of alpha pi by 2 by alpha plus 1 minus cos of alpha pi by 2 by alpha minus 1. And note that alpha is not equals to plus 1 or minus 1. That is plus minus 1. Alpha should not be equals to plus minus 1. So that in simple form, you can obtain it as root over 2 by pi into 1 by 1 minus alpha square into cos of alpha pi by 2. The result will be this. So I hope that you have understood how to solve the problem. Jayanto, you have understood it, the solving of the problem for question number 2 and question number 5 of assignment 6. Any other thing has come? The next one is really typical. I don't know. Can you, Kanchan there has written, if possible, kindly discuss Bessel function or equation. Exactly what do you want to say by this? I'm not clear. If you are attending, can you just give a comment what you want? Because from the Bessel equation, using Laplace transform, do you want how to find out the solution, or exactly what do you want? I'm not sure about it because it is a lengthy process. Do you want that? What we have done for the Bessel?
Sir, only J naught, zeroth order solution only.
That we evaluated.
Yes, sir. In the lecture.
Hmm?
In the lecture.
In the lecture, we have evaluated J0,
Yes.
but JM we have not done. Has he written any comment?
No.
So the Bessel equation, just I will skip certain parts. Of order n, as you know, this is t square d2y dt square plus t dy dt plus t square minus n square of y equals 0. This is the Bessel equation of order n. If you want to find out the solution of this Bessel equation, so please note that Bessel equation of order n is of the form t square d2y dt square plus t dy dt plus t square minus n square of y equals 0. Now you take Laplace transform on both sides. That means you are getting Laplace transform of t square d square by dt square plus Laplace transform of t dy dt plus Laplace transform of t square minus n square of y equals 0. And you know what is the value of Laplace transform of t square d2y d square. Basically, you will use this one, y bar is Laplace transform of yt. If you use this one, then Laplace transform of t square d2y dt square. Basically, this term you can write down as d square ds square of Laplace transform of d2y d square. And you know the Laplace transform of d2y d square is s square y bar minus sy0 minus y dash. So you can do of your own. Similarly, this term, Laplace transform of t dy dt, this you can write down using the formula minus dds of Laplace transform of dy dt. And this using this Laplace transform of dy dt is nothing but s y bar minus y0. So therefore, if you and Laplace transform of t square minus n square of y, this is again, it is nothing but this you can write down simply as y bar double dash minus n square y bar. So if you put these three values, then your original equation, that means this equation, you will obtain as 1 plus s square into y bar double dash plus 3s y bar dash plus 1 minus n square into y bar equals 0. So using Laplace transform, you are converting it into the y bar, where y bar is nothing but the inverse Laplace transform. Now, you have to find out the values of y bar dash, and y bar double dash. Suppose you can assume something like this. Your 5s is 1 plus s square to the power half into y bar s. So that your ys is 5s into 1 plus s square to the power minus half. So that you can, from here, you can find out what is your y bar dash is. You can find out what is your y bar double dash is. This also you can find out. And now if you put this one, sorry, this is not y, but y bar is. So now if you substitute y bar dash and y bar double dash in this equation, then you will obtain an equation in terms of s and phi. So please calculate the values of from y bar s, y bar dash and y bar double dash. If you substitute this in that equation, what you will obtain is that 1 plus s square to the power half into phi double dash plus s into 1 plus s square to the power minus half into phi dash equals n square into 1 plus s square minus half into phi. So that you can write down dds of this, you can write down 1 plus s squared to the power half into phi dash, this term, left hand side term, right hand side term will remain as it is, n squared into 1 plus s squared to the power minus half into phi. So now it is a function of phi and this one. Now if you multiply both sides, by 1 plus s square to the power half into phi dash. Then you will obtain 1 plus s square to the power half phi dash into dds of this. This equals to the n square phi into phi dash, because this term will be vanishing. So you can write down this thing. If you write down, this will be 1 plus s square to the power half into phi dash. dds of this quantity will be there. Same thing, I'm not writing. And the right side will be n square phi into phi dash. So that the right side you can write down, left hand side will become dds of 1 plus s square to the power half into phi dash whole square equals n square into dds of phi square, which implies effectively nothing but 1 plus s squared to the power half into phi dash whole square equals n square phi square plus c. So by putting c equals 0, if you set c equals 0, of course c is the constant of integration, you will obtain this thing. 1 plus s square to the power half into phi dash is equals plus minus n into 5. Now, checking with the knowing formula for n equals 1, we have to choose minus and we have to find out the phi from here. So I am not going through the entire calculation. So from here, if you take minus sign, that means instead of this, if you take minus n phi, and if you evaluate this particular equation, then you will obtain phi equals C1 into 1 plus s square to the power half minus s to the power n, where again C1 is a constant of integration. Any other question is there till now? No. So then we can continue. Now if you set C1 as 1, then you can obtain phi s as root over 1 plus s square minus s to the power n. So that your root over 1 plus s square into this you can write down root over 1 plus s square into y bar s. This is equals to root over 1 plus s square minus s whole to the power n. Since your phi s is nothing but this one. So that from here you can write down your y bar s. This is equals to root over 1 plus s square minus s to the power n divided by root over 1 plus s square. So you got the y bar s from here. You see, you have to find out yt effectively. Now, we are assuming that jnt is the solution of the nth order Bessel equation. Therefore, you can write down Laplace transform of jnt, which is nothing but y bar s. This is equals to, you can write down root over 1 plus s square minus s to the power n divided by root over 1 plus s square. So again, from this formula, you can, if you derive, I think the time is almost not there. Ultimately, you can find the solution as JNT using the Laplace transform. You can obtain so many forms, I think. I'm just writing the forms because that may be better for you. You may just check it using proper calculations because it takes a lot of time. One formula you will get T of J from here itself. Jn plus 1 plus Jn minus 1 equals twice n into Jn. Using the similar kind of identity, you may obtain Jn minus 1 equals Jn minus Jn plus 1 equals twice Jn dash. Please note this one that from here itself you can obtain by using the plus inverse Laplace value of yt, that is solution of the Bessel equation. From there you can find out different identities. That only I am writing this one. Third one you can obtain, that is ddt of t to the power n jn equals t to the power n jn minus 1. And from here you can obtain ultimately one more equation, that is jmt equals minus t to the power m 1 by t ddt of j0t. That is, from the Laplace transform you are finding the y bar s, and then using the jnt, you can solution of the Bessel function, you can find out different properties of Bessel function also. If you wish, I think, Arjun, you can send, post it in the forum also. The entire solution you can post in the forum.
That would be powered in by T dt powered in.
Which one? Have I?
That box part. 1 by T d by dt powered in.
This one.
Yes.
Yes. Minus t to the power m 1 by t d dt to the power m of j0t. So they will post the entire thing. Please remember one thing, again, as I told you clearly, whenever you are solving the problems of Fourier transform, whether for the assignment, whether for the questions for examination, always use for kernel e to the power I alpha x when you evaluate Fourier transform. When you evaluate inverse Fourier transform, then use e power minus I alpha x. Follow this convention since we have done it throughout our lecture like this way. Anything else we have to tell?
You can mention that Laplace
Which one?
integration using Laplace, that concept. First one.
Just quickly let me do one more thing. Suppose we want to find out Fourier cosine transform of e power minus ax cos of x. So from the formula you can write down Fourier cosine transform of this is 0 to infinity e power minus ax cos x into cos of alpha x dx. So this cos part you can break it into cos a plus cos b form. I'm just writing directly the integral. You can find out the integral very easily because cos a cos b formula you will use only. You will obtain 0 to infinity e power minus ax into cos of alpha plus 1 x dx plus 0 to infinity e power minus ax into cos of alpha minus 1x into dx. Now, in both cases, I have to evaluate the integral, that is e power 0 to infinity e power minus ax cos of alpha x dx plus 0 to infinity e power minus ax cos of alpha minus 1x dx. To evaluate the integral, it will take again a lot of time. But try to see this integral, you can see as a Laplace transform of cos x. That is what I want to say. You know it. Laplace transform of cos of, say, bx. This is equals to s by s square plus b square, which means 0 to infinity Laplace transform of cos bx means 0 to infinity cos bx e power minus sx dx equals s by s square plus b square. Just I wanted to mention, if it catches to you that I know Laplace transform of cos ax, cos bx, and if I use this formula, then very easily I can just tell what is the values of this integral. In one case, if we replace b by alpha plus 1 and s, then we will obtain the result very quickly. That is, you can say that 0 to infinity cos of alpha plus 1x into e power minus ax dx. This is equals to a by a square plus alpha plus 1 whole square. Using the formula very easily you can write down. And similarly, you can write down 0 to infinity cos of alpha minus 1x into e power minus ax dx. This is equals to a by a square plus, there it was alpha plus 1, here it will be alpha minus 1 whole square. So that substitute the values of these two integrals and you will obtain the Fourier cosine transform of e power minus ax and cos x. Sorry, I think.
That will be a square. The last integral result will be a square plus alpha minus 1.
That's okay. That they can evaluate it. That they can evaluate it. That is not a problem. So that was a trick. If I remember it, if it comes in my mind that where I should use or when I should use the Laplace transform or Fourier transform, so that it will help me to evaluate the integrals very easily. Is there any other question? If there is no other question, I think let's stop now. Let me thank all the participants, and please note that if you have any query, anything, then please post it to the forum or people will answer it immediately. If you have any query, any doubt, if you are not able to do something, then please inform us. So again, thanking you all. Good night.
Thank you, sir.